Hello everyone. This presentation will cover the work on ensembled and multiple fine-tuned convolutional neural networks for music genre classification from audio spectrograms. Let's start with the introduction. Music genre classification is a crucial domain in music information retrieval. Deep learning techniques, especially CNNs, offer a more effective and scalable alternative compared to traditional methods being complex and expensive. CNNs are highly proficient in tasks associated with the image data classification because they can automatically learn hierarchical features directly from the raw data. And the primary objective of this project is to leverage the power of CNNs, multiple fine-tuning, and ensemble learning to develop a more effective and robust classification model. The model architecture is inspired by the reference work. A core component is our multi-stage fine-tuning, which means MFD. We take powerful pre-trained CNNs like ResNet50, Exception, and EfficientNet B7 and fine-tune them in two distinct steps. First step, on a general acoustic dataset to pre-adapt them to broader audio characteristic. As you can see at the bottom, there are five classes: A, E, I, O, and U, and the number of data is not distributed equally among these classes. Then in the second stage of the multiple fine-tuning, the main task specific GTZAN dataset is used. Then our primary target dataset GTZAN for specific music genre classification is used to fine tune at the second fine tune step. And in the ensembling stage, it is final stage, the model combined the predictions of independently trained ResNet, Exception, and EfficientNet models with the majority voting. Its key advantages is able to reduce the variance and bias in individual models, and it leads to better generalization and higher accuracy. And another method we use is a Gaussian blurring, and it's a standard image processing technique used to reduce noise and smooth out the fine details. In this project, various kernel sizes 3, 3, 5, 5, and 7, 7 are tested, and it shows that 5 multiply 5 kernel size is the most accurate one. So Gaussian blurring with 5 kernel size is applied to our both dataset. And when evaluating the individual CNN models without multiple fine-tuning, recent 50 demonstrate the highest baseline accuracy at the 85%, followed by EfficientNet at 83 and Exception at 80. This highlights the inherent effectiveness of these pre-trained architectures for music genre classification for these spectrograms. And the multiple fine-tuning strategy had varied impacts on individual model performances. For EfficientNet and Exception, MFT led to positive improvements in accuracy with 1 and almost 4% increase respectively. However, for ResNet, MFT unexpectedly resulted in a decrease in accuracy by 4%, unlike the reference paper. This decline could be due to factors like ResNet50's strong initial baseline performance, potential overfitting, or the Vowels dataset not being entirely synergistic with the ResNet's learned features for this specific task. This indicates that while MFT is a powerful technique for transfer learning, its effectiveness can be model dependent and requires careful tuning for each specific architecture to achieve optimal results. And the most significant finding of the study is the superior performance of the ensemble model. It consistently outperformed all individual CNN models, both with and without multiple fine-tuning, and the ensemble model achieved impressive accuracy of 89%, being most successful one in all metric. And this demonstrates that ensembling enhances the overall robustness and the predictive accuracy of a classification system. And while a direct quantitative comparison is challenging due to the inherent differences in tasks and datasets, our results validate the effectiveness of the ensemble learning principle in audio-related classification. Although the best accuracy in our models is lower than the 0.96 in the reference paper, 96% in the reference paper, it is highly competitive within the challenging domain of music information retrieval, which often involves complex acoustic patterns. And this difference can be attributed to the distinct nature and complexity of the classification problems, as our task is multi-class, unlike the binary detection in the reference paper. To conclude, while CNNs and the ensembling strategy enhance the model's performance, MFT caused a positive result on EfficientNet and Exception, but not ResNet50. And overall, this work provides valuable insights and competitive performance on the GTZAN dataset. And here some several feature works can be listed to enhance the performance. And thanks for listening to me.